Okay, this is exam 3, physics 102, s14. Which of these statements is always true? Resistors in parallel have the same voltage, right? That is a true statement. The rest of these can be made true. If the equivalent resistance is smaller than any one of the resistance, the sum of the potentials for resistors in series is equal to the total potential, and the current for resistors in parallel is the same. That's not true, but it would be true for series. It could be true for resistors in parallel if they're identical resistors, but only so. Or you could say the voltage for resistors in parallel is the same, which I've already said. The terminal voltage of the battery is always smaller than the ideal electromotive force because of the internal resistance R. So C is the right answer. What is the equivalent resistance of this circuit? First we take this part, 1 over 1 over 3 plus 1 over 6. That's equal to 2. And then we combine that with a 2 ohm resistor. And so we get 2 plus 2 is 4. For the previous problem, what is the voltage across the 2 ohm resistor? All right, well, remember we have here a 12 volt battery, and we want to know the voltage across this resistor. These are two identical resistors. They're two identical resistors, so they both carry 6 volts. Or you could say the equivalent resistance is 4 ohms, so the current is 12 over 4, or 3 amps. And then 3 amps times 2 ohms gives you 6 volts, which is the voltage across that resistor. So C is the right answer for number 4. For the previous circuit, what is the current through the 6 ohm resistor? Well, I've already said that I have 6 volts here, and so I can say then that because these are in parallel, I have 6 volts and 6 volts. So since I is equal to V over R, that's 6 volts over 6 ohms, which is 1 amp. So that's the answer for number 5 is D. An ohm is a unit of resistance. Consider this circuit. If one of the 2 ohm resistors is removed, what happens to the voltage across the remaining resistor? Okay, well, if you remove one of the 2 ohm resistors, that makes the equivalent resistance of these resistors in parallel to actually go up. So the resistance goes up, and since V equals IR, the voltage is remaining the same because it's 4 volts. If R goes up, that means I has to go down. So C is 7. For the above circuit, what happens to the total current coming off the battery if you remove one of the resistors? Oh, I'm sorry. Yeah, so actually, it decreases. This is actually what I answered here. I just didn't read the question properly. Um, so let's go back to this initial question. If I remove one of the resistors here, what happens to the voltage across the other resistor? The voltage across the other resistor is going to remain the same. I have 4 volts and 4 volts across these. If I take this one out, I still have 4 volts there. And for the reason I stated before, the current coming off the battery, because the equivalent resistance decreases, that means that the current, or excuse me, because the equivalent resistance increases when you remove a resistor, that means the current decreases. So number 8 is C. Sorry about that. Consider the circuit. What is the equivalent resistance? All right, well, first, let's take these. That's 2 plus 2. That's 4 ohms. Then I'll take these. I've already done this. That's 1 ohm. And then combining that with the 2 ohm, that's 3 ohms. So I have a 4 and a 3 ohm resistor in parallel. I'm just going to go ahead and note here that both of these have 12 volts across them. That'll become relevant for the next one. Because these are in parallel. And then let's take the equivalent of that. 1 over 4 plus 1 over 3. That's 1 over 7 twelfths, or 12 sevenths, which is equal to 1.7 ohms. So B is the right answer. Consider the circuit in the previous problem for which resistor is the current greatest. Okay, well, let's see here. On this branch up here, I have 3 amps. 3 amps, 12 volts, and 4 ohms. Down here, coming into this branch, I have 12 over 3, or 4 amps. Let's just say an I is equal to V over R. I have equivalent resistances of 4 and 3 ohms, so it gives me 3 and 4 amps, given 12 volts across each. 3 amps in both R1 and R2, right? However, you could just get rid of R1 and R2 because you know that their currents are identical. And so if they have identical currents, neither one is greatest. And then, so let's see, is it R3 or R5? Let me clean this up just a little bit. So I know I have 4 amps going in. R3 is going to have 2 amps, and R4 will also have 2 amps, and then R5 will have the total of 4 amps. So R5 is the answer. Consider the circuit which the following graph represents the current versus time after the switch is closed and current is allowed to flow in the circuit. Okay, well initially it will have a large current, and then that current will decrease with time by an exponential function. And you just need to know what these look like. But that function will look like this. All right. You might also think that it looks like this because that's also a large current that decreases with time. But the exponential function, which is given I equals I max e to the minus t over RC, that function looks like this. So A is the right answer. 4, 8, and 12 ohm resistor in series with the 12 volt battery. What is the current in the 8 ohm resistor? All right, so I have a 4, 8, and a 12 volt battery. That gives me an equivalent here of 24 ohms with a 12 volt battery. So I is equal to V over R, 12 over 24, 0.5 amps. So B is the right answer, number 12. The third prong in the electrical outlet provides protection from which of these? Not very wet areas. That would actually be for the GFI or the GFCI. Not too much current on a circuit. That would be for the breaker. Not ergoscopy. Yeah, that was just thrown in there. So is B, faulty devices. Remember, if you get a short inside the device, the wire can touch the side of the case, and the case is connected directly to the ground. Consider an RC circuit like this. Find the charging capacitor 10 seconds after the switch is closed. All right, so this is a charging capacitor, and so we need to know that Q is equal to our maximum Q times 1 minus e to the minus t over RC. All right, so you just need to know that this was on your equation sheet, but you need to know that it was what you needed to use. Now Q is equal to CV. That's going to be 5 microfarads times 20 volts times 1 minus e to the minus t, which is 10, and tau, which is RC, is equal to 2 megohms times 5 microfarads. That's equal to 10 seconds. So I got negative 10 over 10. So that's 100 minus, or excuse me, times 1 minus, let's see, e to the negative 1. 0.37, 0.3679. And number 14 is equal to 63. 63 microfarads. So B is the right answer. Which of the following equations is for this circuit is correct? All right, let's see here. I have 6I2 negative 6. That means I'm going in this direction. Plus 10. Okay, that should be a minus 10. So that one's not correct. Minus 6 plus 10. So minus 6 means I'm going in this direction. Plus 10. That's correct so far. Plus 6I2. That's correct. And then I'll come back. So that must be the right answer. 15, there's B. And then 4, well, I won't do the other. Well, no, let me just go 14 minus 4. Oh, it's I3. That should be I1, so that's not correct. And then 14 minus 4I1 plus 6I3 plus 6. Oh, well, that just doesn't need to be there, that I3. So that's not correct. So B is the right answer. Consider the VF circuit. What is the magnitude and direction of the current I2? I2, well, we notice that there's no resistor in the bottom circuit, so we can take this loop. Oh, well, look, our equation was B, so let's just solve that for I2. So you've already found the equation to find I2. So I just say minus 6 plus 10 plus 6 I2 equals 0, and then I solve that for I2. Negative 4.6, which is negative 2/3, or negative 0.67 amps. And it's to the left, so it should be to the right. 0.67 amps to the right, so 16 is C. If switch S is closed, what happens to the current through R1? So I close this switch, This resistance then decreases, and in fact the total resistance decreases, and if resistance decreases that means that current increases. So the current through R1 is going to increase. You turn on a light in a house, what happens to potential across other appliances in the same circuit? Okay, house is a parallel circuit, so the potential stays the same. Consider these wires with currents as labeled. What is the magnitude and direction of I? All right, so let's see, I have 20 amps and 10 amps, so that means right here I have 30 amps, and then I have 5 amps, so I'm going to have 25 amps to the right. So D. Which of these statements about a household circuit is true? It's not a series circuit. They don't all operate at the same current. The total current does increase, and a ground fault circuit interrupt turns off if IN is greater than I out. And that's true too. So 3 and 4, C is the right answer. Capacitor is allowed to fully discharge. Which of these graphs represents the voltage versus time for that capacitor? All right, well the voltage is initially going to be big, and then it's going to get smaller, right? And so it's going to look like this. So number 21 is A. I might change this one actually. I'll see. I might change it. What if instead I allowed it to fully charge, right? In that case, it would look like this. So this would be discharging, and then this would be charging. We'll see. I might change it, but on the test. Battery has an internal resistance of 2 ohms. Its ideal electromotive force is 20 volts. If the current coming off the battery is 5 amps, what is the terminal voltage of the battery? All right, well, the terminal voltage is just equal to E minus I R. So the terminal voltage is 20 minus 5 amps times 2 ohms. That's equal to 10 volts. So A is 22. Consider the circuit. Which of these equations is the correct use of the loop rule? This is different, but look, we just follow loops, just like we did before. Minus I1R1, that's going in this direction. Minus I4R4, okay, that's correct so far. Minus V. Okay, it should be plus V to make that correct, so that's not right. V minus I1R1, that's correct. Minus I2R2. Minus I3R3. Okay, our loop is, that should be plus I3R3. And then you would have another term like a minus I4R4. So that's not correct. Plus I3R3 minus I2R2. So that would be going in this direction. Plus I3R3 minus I2R2. Well, there's a closed loop. That is correct. Let's look at this last one. Plus I2R2. That's going to be going in this direction. Minus I1R1. That should be positive, and then minus V. So this would be correct just by making that positive. Through the circuit, what is the current through the 10 ohm resistor? We'll have 10 volts across each. 10 volts, 10 ohms, 1 amp. Consider the circuit. What happens to the total current if you remove the 1 ohm resistor? Well, if I remove this resistor, the total resistance goes down, so the current goes up. So the total current increases. A is 25. And for the previous circuit, which resistor has the larger voltage? Well, let's see. I think they have all the same. So if I combine these two, I get a 1 ohm resistor. That means I'd have 12 volts here and 12 volts across that 1 ohm resistor, which would give me 12 volts and 12 volts there and there. So I do have the same voltage across all of them. So E is the right answer. And for the previous circuit, what happens to current through the top 2 ohm resistor if you remove the bottom 2 ohm resistor? All right. All right, so what happens to the current through this resistor if I take this one out? Well, if I take that one out, the equivalent resistance of that whole thing goes up. Let's see. I think I might take that question out, actually. It's not quite as simple as I'd expected. So let's just say we're going to cancel that